So the question says simplify fully. If we firstly just look at the first fraction, so 9x squared take away 1, all divided by 3x squared plus 2x take away 1. We've dealt with questions like this before where we factorise both top and bottom and look for a common factor first, and that can sometimes make the maths easier. So it would look something like this, where we factorise and look for a common factor. Now, 9x squared take away 1. If we deal with that first by factorising it and putting it back into brackets, we can use the grid method to help us with that if you need it. So we're going to fill it in, so we know we make 9x squared and negative 1. Note that there are no middle term, so it actually should be familiar to some people as the difference of two squares, but the factors of negative 1 are 1 and negative 1, so that has to be there. And if we think about 9x squared, it could be 1x times 9x, or it could be 3x times 3x. Now, based on the fact it's the difference of two squares, it has to be 3x for both, so that when we multiply that out, they will start to cancel each other out, and we'll see that now. So 3x in plus 1 and 3x take away 1. If we multiply that out, that gives us 3x and negative 3x. So we can see where the 0 part comes from, which is why that is not in the question. So that is the first bit factorised. On the top line we've got 3x plus 1 and 3x take away 1. We now need to do exactly the same for the denominator, so 3x squared plus 2x take away 1. Using the same methods, so we're going to set up the grid to help us. We know it makes 3x squared and negative 1, and we have to make 2x from the other two terms. So the factors are still 1 and negative 1, and the 3x, it would have to be x and 3x. So if we think about the combinations, now the problem is we need to make the plus 2x. If we put 1 in both, and then we'll decide which one must be positive and which one must be negative. If we put negative 1 in that first one in the bottom left, if that was there, that would be negative 1 times 3x, that would be negative 3x, and the other one would be a positive x, and they would definitely make negative 2x, so it can't be that right combination. So that one has to be plus 1 to keep it a positive 3x. Then when we take away the 1, that's going to be negative x. So 3x take away x is 2x, so it must be that combination. So we're going to use this now to put it into factorise and back into brackets. So 3x take away 1 and x plus 1. And this is what we'd hope for. If we look at both the numerator and the denominator, there is a common factor. We've got a common factor of 3x take away 1 in both. Because it's a factor of both, that means we can divide both top and bottom by 3x take away 1. And that is just using equivalent fractions. One of our big ideas. Now you will sometimes see that other books, textbooks or revision sources may actually just cross those out and say they cancel, but this is the understanding behind it. We know we can cancel because we can use equivalent fractions to divide both top and bottom by 3x take away 1. So if we look at that then, on the top row we are left with 3x plus 1, and the denominator is x plus 1. Now this is just the first part. The question then said we needed to divide that by 3x plus 1 divided by x take away 2. Now dividing with fractions, we've learned a little trick, and we've said that we can use something called the KFC method. For those of you who remember it, you keep the first fraction the same, you flip the second, and you change the sign. And how this would look in this particular question, the key part, we would keep the 3x plus 1 and divide by the x plus 1. We would flip the second fraction, so instead of it saying 3x plus 1 over x take away 2, if we flip that, we will have x take away 2 on the top and the 3x plus 1 on the bottom. And the C part is the change in the divide sign to a times sign. Now before you multiply it, it's always a good idea to see if there are any common factors, to save you having to divide through by that same factor later. So if we look, there is actually going to be a factor of 3x plus 1 to both. So again, we can actually divide through by 3x plus 1. If you see that, so it actually is all on one line, that might make it easier, because these would just be multiplied out. This will be just like the one that we did previously. You can see that you've got a factor, both top and bottom, 3x plus 1. So we can just divide through by 3x plus 1 like I just said. But now we can see the big ideas coming in. We are just using, again, equivalent fractions. So if we divide through by 3x plus 1, we are left with x, take away 2, and x plus 1. Now it's worth noting the common misconception. People see x take away 2 and x plus 1 and think their final step to do is divide through by x. But the mistake is there is not a factor of x in all of the terms. Okay, so x is there and there, but there's not a factor of x in this term or that term, whereas because these would be multiplied out, there would be a factor of 3x plus 1 in both. Okay, so just be careful on your final step. There has to be a factor to both top and bottom, to both terms in order to divide.